In this problem, we are told the position of a particle is given by the equation x is equal to t to the fourth minus 10 t squared plus 8t plus 12. And what we are asked to do is we are asked to determine the position, we are asked to determine the velocity, and we are asked to determine the acceleration when t is equal to 3 seconds. Now to do this, the first thing we need to do, we need to figure out a way to relate our position and our acceleration in our velocities together. We have an expression that does this. We have an expression that says our velocity is equal to the derivative of our position with respect to time, or the change dx of our position with respect to time, dt. Now if we take this x right here and we substitute what we know x is equal to, we can take the derivative of that expression and we can get what our velocity is. So this is going to be equal to the derivative of t to the fourth minus 10 t squared plus 8t plus 12. And we take that derivative with respect to t, and we're going to get an expression for velocity. Our velocity is going to be 4t cubed minus 20t plus 8. And this is our velocity. Now what we need to do is figure out a way to relate our acceleration with velocity. And we have an expression that's very similar to how we related our position with velocity. If we look at our acceleration is how fast we're changing our velocity. So this is going to be equal to dv over dt, or the change in velocity over the change in time, or the derivative of velocity with respect to time. Now this is going to be equal to the derivative of the expression we just found for velocity. So it's going to be 4t cubed minus 20t plus 8 over dt. And this is equal to our acceleration. So 12t squared minus 20. And this is our acceleration. Now, I just want to point out that this velocity is going to have units of meters per second. This acceleration is going to have units of meters per second squared. And in order to figure out the velocity, the position, the acceleration when t is equal to 3, what we do is we take the expressions we have and we substitute this t is equal to 3 into them. So for our position x, when t is equal to 3, and let me just write t is equal to 3, this is going to be equal to 3 to the fourth minus 10 times 3 squared plus 8 times 3 plus 12. If we put that in our calculator, we get 3 to the fourth minus 10 3 squared plus 8 times 3 plus 12. And this is equal to 27. So we're at x is equal to 27 meters. Let's look at our velocity. For our velocity when t is equal to 3 is equal to this expression with 3 substituted in for t. So this is going to be 4 times 3 cubed minus 20 times 3 plus 8. Again, let's go to the calculator. 4 times 3 cubed minus 20 times 3 plus 8. And we get this is equal to 56. So this is moving at 56 meters per second. And finally, we can look at what our acceleration is. Our acceleration, when time is equal to 3, we're going to take our expression for acceleration, and we are going to substitute the 3 into it. So this is going to be equal to 12 times 3 squared minus 20, and 12 times 3 squared minus 20 is equal to 88. So this is 88 meters per second squared. Now we know if we are given an expression for position that has a time in it, we can take the derivative once to get our velocity. We can take our derivative a second time to get the acceleration. And if we're asked to figure out any of these, the position, the velocity, or the acceleration at a specific time, all we do is take the time that we're asked to find this for and plug it in to each of these expressions, and we can get our answer.